Hello, in this video, we are going to talk about Python generators. So we've talked about iterables, and I hope that you agree that iterable is something very useful. But at the same time, maybe you also think that they're kind of complicated because if we look at the odd number iterable, I mean, just simply to print out a sequence of odd numbers, there are how many lines of code here? 10, 15 line or so lines of code here, right? That's quite a bit for something that's fairly straightforward, right? So if all we wanted to do is to print out a sequence of odd numbers, we can very easily write a function to do that, right? This function takes no more than 5 lines, right? It's very simple. Wouldn't it be nice if we can turn this function into an iterable? So instead of printing n every time, which is the odd number that we want, we somehow can return this n every time in a for loop as this function is being iterated over. So as it turned out, yes, there is a way to do that, and it's called a generator. Now a generator kind of looks like a function, but it differs in the function, and the hallmark of a generator is that it uses the yield keyword. So let me just kind of demonstrate that. So I'm just going to take this function. I'm going to run it this time. I'm just going to take that function and paste it into my generator. Now, instead of printing it, I'm going to say yield n. And that's it. And that's a generator that will actually, let me demonstrate what it will do. It will do for odd in odd number generator. Let's say we go up to 20, and then we just print out O. Okay, and all right, here we go. It just prints out a bunch of odd numbers, just all the way up to well, not up to not including 20. Okay, so that's a generator. So let me kind of explain how it works. So and it's all come back to this yield keyword. So yield is in some ways very similar to return. Okay, so it returns a number in this case. Now, when the difference is that when the generator is invoked, and we'll talk about how to actually invoke a generator next. Okay, now when the generator can be invoked again and again, the key is that the execution when a generator is invoked does not always start from the beginning. It starts from the beginning the very first time. However, in subsequent invocations, it starts from the statement right after the last yield. So after yielding n, next time we come in this generator, it will actually start from n plus equal to 2. Okay, so let's see an example of how that works. But actually, before we do that, this is one very, very, very important thing that I have to emphasize. So you look at a generator, it kind of looks like a function, but it works very, very differently. So when you call a generator, its code is not executed. Okay, so instead, what happens is a generator object is returned. And so let me show that by doing this. That when you call, I'm calling the generator and give it an argument 20, and it returns something back, right? That something, if I print it out, is not the result of iterating over the generator. It is a generator object, okay? And at this point of time, nothing inside the generator has been executed. Okay, so that's the number one. That's number one important things that you have to realize about generator. So the second thing is, okay, now that we have a generator object, how then do we iterate over it and get retrieve the things back from it, right? So in this case, we want the odd numbers from the this odd number generator. So a generator, it is much like an iterable. So it is in fact a subclass of iterable, I think. So you use it like an iterable. And how do we use iterable? So remember, we do something like this. I'm not going to print it anymore. An iterable, in order to retrieve item after item from an iterable, we call next, right? Now, obviously, before we call next, we have to call a dunder init. Dunder iter. Dunder iter is kind of hidden behind the scene here. We don't really see it here, but we do see, we have to initialize a generator. So the think of this as kind of like doing a dunder iter in this line of code. Okay, and then we call the next and next until the end of the generator, which is signaled by an exception, which is the same as an iterable. The stop iteration exception is reached when we reach the end of the generator, when the generator done the next no longer has anything to give us. Okay, so that's how kind of if when you want to use a generator, you use it like a iterable. Now, to really see how it works step by step, let's step through it, kind of like in a debugger. All right, so on the left-hand side here, I have, using a generator. On the right-hand side, I have the definition of the generator. So we are in this line of code. It calls the generator done the next. What happens is, okay, the execution goes, now that done the next is called, the generator is executed. So we come inside the generator, we now have an n equal to 1, okay? And then that piece of information, n equal to 1, is actually kept around. That's very important, okay? So it's kept around. It goes to the next line of code while 1 less than 20. So that is true. So at that point, it yields n, which is 1. So when it yields, like I said, yield is sort of like return. So it actually returns from here. It returns 1 back to the caller. And that's how 1 gets printed out. Okay? The important thing, though, is the generator and where it is in terms of its execution is still around. So it still remembers that we are at this line of the generator, and the fact that the variable inside the generator n equal to 1, that is kept around. Okay, next thing, we're back to the caller. So we're in a while loop. We go to the condition while true. So we come back here, we call done the next the second time. Okay, when done the next is called the second time, the execution enters into the generator. But remember, the generator was kind of suspended here. So when the execution resumes here, it goes to the line after the last yield. So it comes to n plus 1 plus 2, n was 1. So n plus equal to 2, n becomes 3 now. And then it loops back, right? This is the last line in the loop. It loops back to the beginning while 3 less than 20, which is true. And we come to another yield. So it will yield 3. Again, yield kind of returns. So it returns 3 out to the caller. And that's how the number 3 is printed. Again, the generator is still around. It still remembers where it is in terms of execution. It knows n is now 3. So it keeps repeating this, keeps doing this. Okay, until what? Until when n becomes 21. Now, what happens when n becomes 21 is that it comes back to the beginning, to the loop, checks the condition, 21 less than n is 20. So 21 is not less than 20. So the loop ends, it reaches the end of the generator. There's no more work in the generator. So when that happens, the generator automatically raises stop iteration. And that's how it gets out of the loop in the caller and ends the odd number sequence ends at 19. Okay, I hope that makes sense. Now, obviously, this is pretty ugly, and I've shown you earlier already, I think, that you can use a generator pretty much like in iterable or any of the built-in lists and things like that. So you can use a syntax for O equal to odd number generator 20, and it runs and it prints out all the odd numbers without doing all the ugly try while true, next, and all that good stuff or ugly stuff. Okay, so hopefully that makes sense. Now it's kind of your turn. So remember our Fibonacci number iterable. Now I would like you to write a Fibonacci number generator. So and if you can see immediately how to do this, maybe it will be helpful to write a function to print out the Fibonacci number sequence first, and then you can very easily turn that into a generator. So pause the video, give this a try. Assuming you've done that, it's hopefully you got it right, that the Fibonacci sequence generator would look something like this. Let me comment this out. And we start again. I just keep track of the first n number of Fibonacci numbers. We have n and n plus 1 again, and then important thing is we're yielding n every time, and we are advancing n and n1 the way that we did it before. And when we run this, and there, this is the first 20 or so Fibonacci numbers. And when you compare this, the Fibonacci sequence generator with the iterable version here, this is the generator version compared with the iterable version. I hope that you see, the generator version is really a lot simpler, and also it's a lot more readable. Okay, and before I leave you, I just want to say one more thing about yield. Yield is actually does a lot more than making a function into a generator. It's very powerful. It kind of enables something called coroutines. So if you're interested, I have a link here for your reading pleasure.